Take a look at this code. Need code 1249 minimum remove to make valid parentheses. Given a string s of left and right parentheses and lowercase English characters, your task is to remove the minimum number of parentheses in any positions so that the resulting parentheses string is valid and return any valid string. Formally, a parentheses string is valid if and only if empty contain only lowercase characters, or it can be written as AB, A concatenated with B, where A and B are valid strings. It can be written as A is valid string. Okay, I know what it is. So this is a string, and it's not balanced because of this character. If we remove this character, it again became balanced. And instead of remove this, we can remove this character. Again, left and right, they are balanced. Either way is acceptable. Here again, this one is imbalanced, have to be removed. Whatever left is the answer. So then we go this problem, this imbalanced have to be removed, and whatever left is also imbalanced. So both of them get removed, we get an empty string. Again, let's look at this. Left, 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 right, right. Okay, this is balanced, this is imbalanced, so we remove this. I think I got a solution. What we can do is we can use a stack, and whenever the stack is empty and we need left parenthesis, we ignore it, and finally, after we reach the end, whatever is left in the parentheses should be removed. And that solution processed each character once, so it's O(n) time complexity. The space complexity will be O(n) as well. In the worst scenario, all of those parentheses are put into the stack. So O(n) and O(n), this looks like a reasonable solution. Let's start coding. We have a string. Let's first create a stack. We need to import Java util. A stack of characters instead of characters. We say it's parent. I don't know how to spell it. Parentheses. Okay, let's copy this. Parent. A parent. Parent is good enough. And equal new stack. Instead of use stack, we can use a more efficient data structure. We can use DQ. Right, we can use a DQ. DQ. Now we have this parent. What we do next? We can iterate through the string, and we need a string buffer. In this case, string buffer for new string buffer. This used to store our final result. And what else we need? We need to string for loop for character inside the string to char array. String is converted to char array, and we process each char if c equal left parenthesis. Then we need what do we do? And okay, and what do we store in the stack? Not a character. We need to store the index. Store the index of that character, so later we can remove it. Integer, and we have a int of position, which is at index 0. We start from index 0, and we keep increasing it. If this is after parenthesis, and we need a counter. Int. Do we need a counter? No, we don't need a counter because we already have a stack. If c equal left parenthesis, we do parent push the current position, else if c equal the right parenthesis, what do? We need to see if what we need to remove instead of besides the stack. Besides the stack, we need another data structure to store the position we need to remove, right? So now let's get a list of integers. Remove equal new array list. Now this is used to remember which position we need to remove. Else if c. Now we have two scenarios. If the stack is empty, right? There's nothing to eliminate this character. What we do is remove, add a current position. Else it's not empty. Then the stack pop 1 out from the stack. Else, what do? We don't do anything. We're totally fine. So finally, after the for loop, we need to if the stack is empty, if that is not empty, that means we have some left parentheses to remove. Remember, at each of the steps, no matter what we do, the position need to be increased. We just finished the process to one of the characters. At the end, the stack is not empty. Then what we need to do is while stack is empty, while stack dot, oh, not stack, parenthesis is empty. Is empty, is not empty. We just remove, add, parent, pop. Okay. Now we have this remove. We have this remove list. Then what do? We are supposed to iterate through the original string. Whenever we encounter remove, we should skip it, which is not optimum if we use a list. List is not good. In this case, let's not use list. We use set instead. If we use hash set, the operation cost is 1. Okay, now we have this remove list. Then let's get through for int I equal 0, I below, but the input is s length I plus. Okay, and we need a char. We can use char. We don't need we don't need to change it into an array. This is not necessary. It's more efficient. Why we want a char? That's not necessary. So here, let's do this kind of loop for char c equal yes char at child position I. Then we deal with that. Same thing here. Then get a character char at. So if remove contains, if that contains I, that means we don't do anything. Otherwise, remove not contains is get to be append to the string buffer as char at I. Now we have that string buffer ready. What we need to do is we need to return the content of that string buffer to string, and we are done. So time complexity is O(n) because we process each character. Space complexity is O(n) as well. At most we store n characters in a queue and remove all of them. So those two. Now let's position 0. Should we store the position 0? Not necessary at this point because we now have index. Why have the index? We don't need this position anymore. Let's remove it. And here let's push in index. We don't need to increase this. That position is our I. And the parent. And now, if parent is not null, if that's empty, we don't do anything. Not empty. We add everything from the parent into this. Now, we avoid anything in the remove and append. So this should work. That's one thing. Empty string. If we have empty string, what do we do? Empty string return empty. With that, yeah, let's treat it as a special case. If s equal null or s length equals 0, return s. No need to create this data structure unnecessarily. Okay, let's run the code. Cannot find symbol, parent, stack, new deck, oh, deck, I don't like the deck, deck, run the code, dq, dq, is that? Oh, okay, sometimes. Let's use stack instead in this case. Run the code. Let's submit. You output this. So you output this. Left, right. Those two should be expected empty. Why you are not removing them? If I see a left parenthesis, oh, yeah, I push. If it's empty, you are directly candidate. Otherwise, I pop. If if parent not empty, while not empty. Oh, come on. It's not very satisfactory, but yeah, that's probably the solution.